Okay, welcome back to chemistry. We're going to jump right into atomic structure, which is our first unit. I promise that you will see me actually in the next video. There's just really no reason for it yet. But atomic structure, what is it? So the kind of straight definition of it is that you have a positively charged nucleus, which is like your middle portion of your atom, and these negatively charged electrons that are circling and flying around it. An example of atomic structure is what gives energy to atoms and then to molecules, which will make more sense once you see the picture on the next slide. So over here on the right side, you can see this is the picture. This is an atom. So when I said you have a positively charged nucleus, it's right here in the middle, and you have all those negatively charged electrons flying around it. That's those green things. You've probably seen the picture of an atom before, so all we're doing is giving you some vocab so that you can associate the two together. There are three what we call subatomic particles in an atom. So you have the protons, found in the middle. So in this case, it's these blue circles. You have neutrons, also found in the middle, these red circles. And electrons found in what we call the electron cloud, aka they're just floating around, all that stuff in the middle. So these things are out here in the electron cloud, everything else is in the middle. These three words you're going to become very familiar with. We're going to be using them for the whole year. So learn them now and it'll be a lot easier on your part. So just another view of it, one that looks a little bit different. Again, you've seen it before. Protons and neutrons right in the middle in the nucleus, electrons flying around the outside. Something that we're going to get into a little bit now, but more so in a later unit, are the charge of these subatomic particles. So what charge means is it positive, is it negative, does it have no charge, is it neutral? Or you can think of like a battery, like it's electricity. So your protons in the middle, those have a positive charge. Your neutrons, which are also in the middle, have a neutral charge. They have no charge. That's why your nucleus is overall positively charged, because you have these two hanging out in the middle. The electrons in the cloud have that negative charge. But we want to kind of focus on, okay, which two are going to affect the overall charge of that atom, of that element. So like I just went over, we know protons have that positive charge, neutrons have that neutral charge, and electrons have that negative charge. So the only two that are going to really ever affect the overall negativity of your atom are these protons and these electrons. Why do we need neutrons then? If they don't have a charge and they don't affect the overall charge at all, why are they there? Why are they in the middle of your atom hanging out with the protons? It's a super important reason. Surprise! The atomic weight. So every atom has, no matter how small it might be, a weight to it. Okay? And that's what the neutrons are kind of there for. So protons and neutrons, those two things in the middle of your atom, each weigh 1 atomic mass unit, or AMU. We're not going to focus too much on this unit. All you really need to know is that they are worth 1 unit of weight. Those electrons that are floating out in the electron cloud basically are so tiny that they don't weigh anything, so they don't affect the weight of our atom at all. So whenever we're talking about weight, we don't even need to think about electrons. So your atomic mass, or the weight of your atom, is going to equal the number of protons and the number of neutrons, which actually makes it super easy, as you're going to see here in a second. I have a little example. So this is the same picture you've been seeing. It looks a little bit different, but here are your protons and neutrons in the nucleus. Here are your electrons out in that electron cloud. Again, what we know, protons and neutrons each weigh 1 mass unit, and electrons, these things don't weigh anything. So what's the weight of this atom? Easiest way to find out, just count what's in the middle. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 6 protons and 6 neutrons, 12 things in the middle overall. So the weight of this atom is 12. 12 AMUs. That's really all it is when it comes to counting to figure out the weight. The benefit to chemistry, though, is you have this beautiful thing which you've seen before, hopefully, called the periodic table of elements. So we don't even necessarily every single time have to go count the protons and neutrons, figure out the atomic weight, figure out the number of all the electrons, because the periodic table has done a lot of this for us already. All right, so I'm going to zoom in on our element carbon right here for a second. There it is. So carbon. Carbon's symbol is a C, C for carbon. That one's pretty easy. Some of them don't make a ton of sense, so that's why I picked this one. But this big letter right here kind of tells you, okay, this is the symbol, this is what element it is. The number at the bottom of the box, in every box for every element on that periodic table, is your atomic mass. So how we just counted those protons and neutrons, that number is right here. Up here, you have your atomic number. This is going to be your number of protons and your number of electrons. Super easy for you. They are, for the sake of right now, always going to be the same number. So if I go back for a second, this is that picture that we just looked at. We noticed that we had those 6 protons that we counted. Here are those 6 electrons. So we have the same number of protons and electrons. And then like we counted, our atomic mass was 12. Our atomic mass right at the bottom is 12. So that atom that we just looked at was carbon. All right, the nice thing is every box in the periodic table is set up in the exact same way. So you know, okay, the top, that's my atomic number. That right there tells you how many protons you have, how many electrons you have. The number at the bottom is going to tell you, okay, what's the atomic mass? What is the number of protons plus the number of neutrons? So we're going to look at kind of another example. Now I've given you the box with element nitrogen, and I want to know what the answer to these questions might be. So my first question, and you can pause this video and try and answer it for yourself. I'd recommend doing that. Otherwise, I'm just kind of going to go through them one by one. Hopefully you get more familiar with that, how this setup looks. So my first question, okay, what's that atomic number? Well, if you remember from carbon, that atomic number is right there at the top. It's one of the most important things. So nitrogen's atomic number is 7. How many protons does nitrogen have? Again, going back, well, we know that the atomic number is the same number of electrons and protons. Therefore, if nitrogen's atomic number is 7, it has 7 protons. And down here, how many electrons? Also 7. So this number right here, boom, 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 answers all 3 of those questions. Fourth question on my slide, what's the mass? Well, there's only one other number on here. You have 14.007. A good way to remember, and that is the mass. I didn't answer that. Good way to remember that the bottom number is your mass is because you kind of have this funky little decimal going on. Your atomic number is always going to be a whole number. So whenever you see a decimal like this, you can kind of immediately think, okay, that's the weight, because it's just an average. And then down here, I want you to pause the video because my trick question is, how many neutrons does nitrogen have? We want to think about how could we figure that out. My hint to you is if we know this number is the weight, and that's just the number of protons plus the number of neutrons, and up here I have my number of protons, it's kind of just a simple math equation. So try and pause the video and figure out how you can use these 2 numbers to figure out your number of neutrons. Otherwise, I'm about to just kind of run you through it. Okay, so here is the weight. Here's the number of protons. I want to know how many neutrons I have. All I need to do is subtract this number from this number. So 14 minus 7 happens to be 7. So that means I have 7 neutrons. Because you could think, okay, 7 neutrons plus 7 protons gives me that weight of 14. It's a pretty simple addition subtraction. Never gets that much more complicated. And I did round. I didn't do 14.007. I just kind of said 14. But you have 7 neutrons. We're going to go over that a little bit more in class. So it will take some practice for you to kind of get that stuck in your head on how that works. But a good thing to remember, especially on that unit test that's going to be in a couple of weeks here, is the number of neutrons, subtract the bottom number, or the top number, sorry, from the bottom number. All right, and we'll do one more example for the sake of this video. I've given you aluminum, okay? Same setup. I know I have my atomic number. You can pause this video. Now is your chance to do that. If you want to try and answer these questions on your own, I'll give you a second to pause it. So if your atomic number is 13, that means your number of protons is 13. That means your number of electrons is 13. So protons and electrons go hand in hand for now. We're not getting into when it's different yet. You can always assume for this first unit that protons and electrons are going to be the same number, and that's this top number. Now I want to know what's the number of neutrons. So same thing we did on that last slide. Well, I know my total weight. I know my number of protons. Therefore, I kind of know that the weight minus the number of protons gives me the number of neutrons that I have. So for this, I'm going to round up, say it's 27. So I would take 27 minus 13, and I would get 14. And those are my answers for that one. Hopefully that makes a little bit of sense. Again, we're going to be dealing with the periodic table so much that you will have it down. It just does take practice. What I would recommend for you is to kind of just pick a few random elements and try and answer these 3 things for any given element. It's all done the exact same way. What I want you to do is there is a corresponding sheet that talks about atomic structure. I want you to go ahead and fill that out, do your best with it. And then I think your next video that you're watching next time you're online is about nuclear and hyphen notation. All that means is a different way we can kind of write out every element on the periodic table. Thanks for watching. Email with any questions that you have and do your best with the homework.